And this is our last notes for 5-6. So let's dive right in. So we have a new theorem called the Hinge theorem. The Hinge theorem says that if two sides of a triangle are congruent of another triangle, then the included angle of the first is larger than the included angle of the second angle. So what that is trying to say, and again, this is the Hinge theorem, and I'll position that a little bit better. The Hinge theorem says if you have two triangles with two angles, so 43 degrees is obviously bigger than 30 degrees. So if we have angle A, which is bigger or larger than angle F, then the sides opposite of those have that same thing. So angle A, the side opposite of angle A is BC. So BC is going to be larger than the opposite side from F, or 30 degrees, which is GH. And the converse is basically the exact opposite. It's the converse of the Hinge theorem. The converse of the Hinge theorem says, so last time we had angles to sides. This time it's sides to angles. So we have two sides, JK and PQ. JK is 8, PQ is 12. So JK is smaller than PQ. So we can say PQ is larger than JK. Then the opposite sides of those, or the opposite angles, have that same not congruency, inequality. So angle R is going to be larger than angle L, or the sides opposite of, or the angles opposite of those sides. So let's use that fact. In A, you have to compare the given measures. So we have WX and WX has 3, and I'll make XY have 2. So WX, what I'm trying to say, oh yeah, so angle WZX is 51 degrees, and angle, let's just type that out, and angle YZX is 55 degrees. So by the Hinge theorem, the larger degree is across from the larger side. So obviously 55 degrees is larger than 51 degrees. So then we can say side here by the Hinge theorem. We can say that XY, the side across from the larger angle, is larger than WX. And that's it. That's all you do. I want you to try B. Way to go. You did it. Find the range of possible values for X. So this is a harder problem. So to start off, I'm going to type this stuff because it's neater. We have JE is larger than EG. Obviously, 11 is larger than 9. So we can say that JE is larger than EG. That's not according. I have no idea if that's spelled right. According to the converse of the Hinge theorem, the angles across from it, the angle across from the larger side is larger than the angle across from the smaller side. So we can say that angle GHE is larger than angle GH. The first one's JH. Yeah, I wrote it right. GHE. So if we know that, we can set up a little equation. We can say that the two parts, so JHE is 6x plus 15, has to be larger than the degree measure of 65. So we can solve that. First, we're going to subtract 15. And that'll get us 6x larger than 50. Is that right? Yeah, that's right. And then we're going to divide by 6. So I'm just going to make a line like this. No, I'm not. This is divided by 6. That's a G. And that'll give us x is greater than 50 over 6, which if you simplify it is 25 over 3. And you can just leave it like that, or if you care, it's 8.3 repeating. So we found that. Or 8.3333. I don't write that. 8.33 repeating. So we found that. However, all this says is x is greater than 25 divided by 3, or 8.33. We could also, so that's what that's saying is we could put in 100 for x. So we have 615 degrees, which that can happen. So in triangles, they can have a max of 180 degrees. So this is where it gets kind of weird. So the other part to this is, so we found the lower part. We also have to do 6x plus 15 has to be less than 180 degrees, or as many degrees are in a triangle. So these problems basically have 2 steps. So we solve for this again. Subtract 15. So 6x is less than 165. And then we have to divide by 6. And again, this is divided by 6. So we get x is less than, and this would reduce to 55. Let me go to my cheat sheet really quick, just to make sure I'm not being crazy. Yep. Not 55. 27.5. That was closest. So what this is saying is we have something that x is greater than 25 over 3, or 8.33, and less than 27.5. So we write that as a combined inequality, or a compound inequality, of 8.333 is less than x, which is less than 27.5. And that's our answer. Those are kind of harder. That's probably the hard part of the section. Let's move on. So now we have everyone's favorite, the proof. Let's do this. So first step to any proof is given. We're going to try to prove that EB is greater than ED. And since we just learned the hinge theorem, or the converse of the hinge theorem, we're going to use that. So let's start off. Write the given. And mine aren't going to have the congruent symbols over them just because I'm writing. So we've given. So next step, what do we do? Well, the book says to do this. AE is equal to AE. And I can't figure out why. Actually, I remember why the third side has to be equal and to use the hinge theorem. The 2 sides have to be equal. So now we have this side is equal to itself. So now that we have that, we can start using the hinge theorem. But first, we need to compare an angle. So by the angle addition postulate, we have the 2 parts of angle EAB will equal the 2 little angles it makes, EAD plus angle DAB, or DAB. And that's by the angle addition postulate. And because I'm short on time, let's just go over to this one. So angle addition postulate, then use the inequality, and then you use EB is greater than ED. Your job is to finish the last one, and it's making me leave, so you can ask me questions.